So we wanted to give you guys a look at our Smithy lathe mill drill. That's what we're going to be talking about today. We want to show you guys some of its features, some of its capabilities, some of the optional equipment that I got with it, and we'll take a look at some of the tooling that we have for it as well. So it's a lathe. It's set up as a lathe right now. I have a compound rest on this table and quick change tool post with a cutting tool in there. Then I can also take this compound rest off of this table, and this becomes the milling table. Then I can swing this head in over it, and I can still use my power feed in the two directions while I'm doing milling operations. And it's also a drill. If I disengage this, the hand wheel is disengaged, and I can just use it like a drill press. You can use this lever to engage either the lathe or the mill. So here, the mill is going to spin. When it's over here, the lathe is going to spin. This is the electronic motor control, like speed control for the motor. It's the higher you turn it, the higher it spins. On and off key for the whole machine, forward, reverse for the motor. That's where you get your reverse, emergency stop, of course. This is an overload reset. If you were to work the electronically controlled motor too hard, this would trip and prevent damage to the motor. This is the quick change gearbox over here with our 1, 2, 3 selector and our 1 through 7 selector. And by using this, we can get a wide variety of different threading combinations and feed rates. And there's charts up here that show us all that. We've got the thread chart here that shows you what combination to use to get what pitch of thread. And then we have a chart for longitudinal feed rate and a chart for cross feed rate. And then there's a section for metric threads. There's also, this came with another set of gears that I can exchange in the back to go from SAE to metric threads if I wanted to. And then moving upwards here, these are locks that lock the rotation and also the height adjustment of the milling head and drilling head. And this is a crank where you can put the handle on there and crank this head up and down. Now it doesn't travel up and down all that far. Also the quill for the milling machine and drill doesn't travel all that far. So when I'm making setups, I have to be super careful that I'm within the zone of all of this, because just for example, this drill chuck sticks out a huge amount from the spindle, and then a drill is going to stick out of it however far. So that's like quite a bit of space. Whereas when I put collets in this spindle, it's an R8 taper in this spindle. When I put a collet in there with an end mill in it, I mean, it's only going to stick out this far. So I've used most of my travel up just switching from one to the other.
So what you doing now?
Well, I'd like to show you guys some of the features that this machine came with. And we're not actually doing any cutting today, but I just want to show you all the different things actually up on the machine. So we're starting with the 3-jaw chuck for the lathe. It's got two different styles of jaws. One that can only hold a workpiece on the outside, so I call these the outside jaws. Now this can hold a workpiece on the outside or a ring on the inside, but just so that I can have a different name for each set of jaws. These are my outside jaws, these are my inside jaws for the 3-jaw chuck. Just kidding. Okay, so this is our 4-jaw chuck, and it only has the one set of jaws, but they are reversible. And because each jaw runs on its own independent screw, whereas the 3-jaw, all the jaws run together on a scroll, and that's why these jaws can work when you flip them either way. So they are now, I guess you would call them inside jaw configuration, and if you spin them, they're in the outside jaw configuration. The thing about the 4-jaw that makes it cool, it's slower to use because you have to dial in these jaws all individually. Whereas the 3-jaw, you turn one handle, everything centers on its own. But the beauty of this is I could put a square in there, I could put something that's just some bizarre, gross shape in there, and I can manipulate the spinning face of it to whatever position I want. I could even reverse, say, only one jaw and have like, say I had a handle in here and I wanted to machine a hole in the handle, then I could hold it up close to the small round part with 3 of these, and then the other one could be sticking way out here holding the handle part of it. So it's really useful for all kinds of bizarre shapes.
Molly, shut it.
This is the faceplate. It's well, it's an 8-inch diameter faceplate. I forgot to mention both of my chucks are 6-inch diameter. And you can see this has T-slots in it.
T for Tanya.
So I can put T-nuts in there and clamping studs, and I can clamp any old, well, anything that'll fit in here, I can clamp on here if that's the sort of thing that you're working on. So I'm just setting up to clamp some just random piece in here just to show you guys a possible example of, you know, what you can do with this thing.
Molly, shh. We're trying to video here.
So here's just some random thing I have clamped in here. We could drill and bore holes in here. We could tap it. We could position this just about any way we want, and then we can do lathe work on this thing. It's the 3-jaw chuck that normally lives on here, because most often the things I want to work on in the lathe are already round, and so that's why this guy lives here until I have something quite unique to do, and then I'll get either the 4-jaw chuck or the faceplate out.
Okay, go.
So right now it's set up as a lathe. This is the tailstock. I've got the live center in there right now, which means that the part that holds the rear end of the shaft is on bearings to reduce friction and so on. I can also put a drill chuck in here and drill with this. And of course I can move this anywhere up and down the bed that I want to. Set up as a lathe with the compound rest and a quick change tool post. So the idea behind this tool post is just with the swing of one lever, you can pull out one tool and put the next one in. So the reason I have so many tool holders is because there's so many different kinds of tools, and I like to have them already preset to the proper height. So the tools are at different heights just the way you get them. And so if you only had one tool holder, you'd spend half your life adjusting the height of those things up and down. So this way, you can see here I've got this is the radius grinding tool that we made not too long ago in a video. I can put different boring bars in this holder. I've just got a carbide button in this guy. This guy's empty right now. Here's a right-hand brazed tip carbide turning tool. Here's a right-hand indexable carbide insert tool holder inside this. And here's a left-hand turning tool, carbide again. And I've got my part-off tool and my knurling tool. So those are some of the common things that I'll use when I'm running this as a lathe.
Come here. Sucky.
So I've got this pretty long piece of 1-inch diameter stainless bar in here, wanting to show you guys the use of this steady rest here. So I've got the bar in the 3-jaw chuck, which is going to spin it and support this end of it. The steady rest is going to support this end while I face it flat, because you can see it's just looks sheared right now. It's a real mess, the end. So I want to face this end flat, and then we're going to use our center drill to put a hole in it, and that way we can hold this shaft in our live center, and then we'll take the steady rest off and we'll set the follower rest up and show you guys how that works. So you can see and hear that intermittent cut right now. What we're doing is we're truing that end up, making it nice and flat. Partially just because, and partially because I want my center drill entering into a flat surface so it doesn't get swayed off to one side or the other. I am spinning this pretty slow right now, this bar, because there's like 3 feet of it sticking out the far end of the headstock there, and I don't want that whipping around too fast and potentially bending and turning into a huge flailing club type thing. So now our face here is reasonably cleaned up, and we're just going to put a center hole in here so that we can run this with our live center. This is stainless. It's right ignorant to machine, so you don't want to over force center drill. There, nice center hole.
There you go.
So you see with no support, this bar is pretty floppy in here. There's got to be 3 feet of it sticking out. So that's why we put this center hole in here. I can't do anything if you're right here.
Fine, I'll go over here.
Why don't you go over there?
I don't like it over there.
Jesus. So now that's well supported. We can machine this thing. But now if we were cutting way out in the middle, we would very quickly find that we still didn't have enough support. And that's what the follower rest is for. So we're going to set the follower rest up now. Yeah, I thought so. So
What's wrong?
nothing's wrong.
You said you thought so. What'd you think?
Well, this follower rest fastens down to these plugged holes. So the idea is those plugs are in there to keep these threaded holes from filling up with chips. So I'm going to take these plugs out, clean the surface off really well, and that's how I'm going to mount the follower rest with bolts down into those holes. So this is just a mock-up. I'm not actually going to take a cut here. A couple reasons. One is I would just be kind of wasting a perfectly good brand new piece of material. Also, we can't find the bolts that came with these, and those are metric threads in there, and so we can't actually fasten this down. But still, it shows an example of what this thing can do. So it can offer support way out here in the middle. So instead of chattering around, this thing is well supported. Now, in this case, it wouldn't be following the cutting tool. It would be leading the cutting tool, which only makes sense because you've got a perfectly good diameter up here, and we'd be changing the diameter here. And so that's why we're using it to actually to lead the tool with offering support. Well, that's our description, you know, a few different accessories with the lathe and a few different little processes with the lathe. Now we're going to move on to the milling machine part of this lathe mill drill. So this is one of the extras I got with this machine. It's a rotary table. It also can be used as a dividing head. It has a complete set of dividing plates. I believe I can accurately index between 2 and like 1,001 holes and have them equally spaced on a bolt hole circle using this thing. It also has 360 degrees marked out with a pointer, and up until now that's all I've used. So now this the rotary table itself has T-slots in it, and I've made this adapter to go from the rotary table to this 4-jaw chuck I have for holding oddball shapes. This rotary table came with a tailstock here, so I can work on longer pieces, and it also can be used in the vertical position for doing drilling, milling, whatever it is you want to do in that position. Another option I got with this machine is this riser block. It's full of T-slots. I can clamp work pieces to it, and if I need the extra height, because I can't get this all the way down to here, so there's times when you just need extra height. That's what this is for. One of the things I can clamp down on my riser block is this machine vise.
Wrong?
I have a sliver.
Yeah, boo-boo.
Stop it. I need better light. So that's about it for the features and some of the operation of. It went through a couple setups and went through some of the accessories I got with this thing. So a few likes and dislikes about it. First of all, I love having it because it's so versatile. I mean, if it'll fit in here, there's not much you really can't do with this machine. So that's awesome. Being 3 machines in one, it's a bit of a pain in the ass because you're forever resetting it up, but you use up a lot less real estate, and it's also a more economical way to go to have all those capabilities. Now, I've been wanting one of these for probably 30 years, and I used to drool over these in the back of Popular Mechanics magazine, and I remember them being about $3,500 US, which would probably translate to about 6,000 Canadian. And they were actually made in the US, and the quality, you know, showed. Well, they're no longer made in the US, and that shows. And I can explain a couple things that were disappointments on this. One example is right here, where you select whether you're sending the motor power to the lathe or to the mill spindle. Well, the pin didn't properly go to either hole. It didn't make it all the way to one hole, and it wanted to rest past where the other hole was. So just you know, little fine details, workmanship. This little guard right here, it's what separates your cross feed from your length feed. And when I got this thing, it actually come with this loose. And the very first time I used it, I was coming out of cross feed, and this thing had rotated a bit. So it automatically went into lengthwise travel, blew up my carbide insert because it was crashing into the end of the piece I was working on. So that was disappointing. Another disappointment is here on the thread chasing dial. This is what, you know, it's right beside the split nut. So when you're chasing threads, it's these numbers you want to be lining up. Well, they don't line up. They kind of line up here and here, and nothing lines up. But nothing lines up.
What else?
Some of the castings, this is the bottom of my follower rest, and some of the castings are kind of shoddy. You can, in the machining is kind of shoddy. You know, you can see this thing wasn't even like cleaning up properly. There's big chunks that were missed that weren't machined at all. So that's always disappointing when you spend a lot of money on something. Oh, incidentally, what was $3,500 US 30 years ago is now $13,000 Canadian. So that's a little less quality, a lot more money. I guess that's fair. Another thing I'm not super crazy about, they didn't provide any provision to protect the motor, and it's right here, right beside the action. Now, I temporarily have this paper towel just to catch any oil that comes this way, stop it from trying to seep into the motor, but this, I'm just not happy with this. Very soon I'm going to build some sort of guard, waterproof guard that completely isolates, still allows air travel, but completely isolates the motor from my cuttings and oil and cutting fluids, because that's just a blown motor, I think, waiting to happen, just sitting right there so close to where all the mess is. So this isn't like a build quality complaint. This is just fact of the matter. A lathe would have a much smaller cross slide. Because this is also a milling table, it's so massive that you have to be very careful where you place your compound rest, for example, when you're using this as a lathe, because this the quill on this tailstock has a limited amount of travel, and you actually can have trouble reaching all the way across this to get at the end of your workpiece with a drill or a center drill or something like that. So this huge table just adds to the complexity of setups. Oh, another thing in shipping, I mean, this isn't the end of the world, but it showed up brand spanking new with a big chip out of the paint here. It just wasn't packaged well enough and got damaged during shipping.
It's the end of the world as we know it. Mm-hmm.
I do have these, the stand was an extra that I got with the machine, and I'm happy I did that. It matches it really nicely. I keep different odds and ends in here. This is offset boring head set. only used it a couple times, but for the price, it's actually, I'm pretty happy with it considering it was, somewhere around $250, I think, $300. This one I keep my metric change gears in here. I keep a bunch of my my collets in here for the R8 milling spindle. So for milling, I have this set of 20 pieces, 10 slot drills, 10 end mills, and I'm super happy with this. It was $200 for 20 pieces. So on average, these are $10 a piece. I mean, and some of them are small, sure, because you need that, and some of them are big. But on average, $10 a piece. And I thought that was awesome. I thought they'd be absolute crap, and they're not. I can't believe these are standing up as well as any end mill and slot drill that I've used.
What brand are they? Do you know?
China.
China.
For micro adjustment of the longitudinal feed, when you want to do precision milling with this, when you're not wanting to use the power feed, but you want to do actual precision milling, this is a little bit of a pain in the ass. So this is the micro feed handle that you would use. And the way it works is you disengage your quick change gearbox, you engage your split nut, your threading nut, and then you can use this dial here, this incremented dial, and make movements down to, half a thou or a thou or whatever you want. But what I don't like about it is, how do you have your workpiece here, your hand here, like it's just so far away from the action. It's a little awkward. Like if I want to have say I'm holding a piece of paper and I'm waiting to feel an end mill touch the edge of a workpiece, then I'm trying to look at it and this hand's way over here moving this table along. It's a little awkward is all.
Yeah, I think your arms are just too short.
So as far as being a drill press, I'm not going to spend a lot of time on that. I think it's pretty straightforward. You put a drill in there, you have something in a vise or clamp to the table, and then you've got these handles. It came with 3 handles. I just have 2 of them out because it's very rare that I use this as a drill press. If anything, I'll kind of rapid feed this down, then put it back into the micro hand wheel, whereas I actually use this for milling. So as I said in the beginning, I am super happy to have this. You've heard some of my gripes, and just wanted to share that with you guys in case you're interested in something like this or been looking at one. Showed you some of the features and some of the optional equipment that I got with this, and we talked a little bit about some of its capabilities. And so that's gonna basically do it for today's video. So that's about it for today's video, guys. We've talked about some of the likes and dislikes of this machine. Again, overall, super happy to have it. And that's about it for today.
Okay. Thanks for watching. Please like, share, and subscribe. Bye for now.
Bye for now.